Hello everyone, welcome back. Today I'm going to be going over Lab 10, and then I'm also going to be going over your assignment, which is going to be due next week, which is your food safety project report. Parts A through D are going to be due. So on 5/1 by 11:59 p.m., please turn in parts A through D. So I have this revised template up, and so now the hyperlinks for this are going to be working. So the parts that I want you to fill in everything all the way to D. So that's including here. So you'll stop at E, okay? So don't do E through H. All you need to do right now is just A to D. And then next week I'll give you a little more information on how to answer these. And then everything will be due. So if you could, I'd appreciate it if you all sent me any questions you have about this. For part D, you're going to need to go to these sources. So you can just open the hyperlinks for each one of these and then see what you need to do. Okay. So now it opened up. So let's say your food is honey. So you can search for them here. So honey. And then the English one, click the check mark. Then this will give you information about honey, the processes that need to take place. Okay, so possible contaminants, labeling, all that stuff. So make sure to fill this all in, all the way, finish D. So for this one, make sure. Okay, so just read all the directions. If you have any questions, please make sure to email me as soon as you have them, if anything comes up. Okay, so for Lab 10, we're continuing our food project. Fun. Okay, so food safety and pathogen analysis. So these are the things we would have been. These are the things that we would have been doing, but we're not. So the whole point of selective plating or differential is really to observe different colony morphology. So with selective, only certain organisms are going to be able to grow on that plate. So that's going to cause it to look different than another organism. So for example, here we have E. coli. There's a lot of growth. It grows very well on this McConkey agar. And then the E. coli 157 has very light growth. So this is going to allow us to differentiate between them. But this is going to be selective because it's selecting for this organism. And then you see here how the E. coli 157H7 is red, and the other E. coli are blue. So that's going to be differential. So that's going to allow you to differentiate between the two of them. Okay, and this is going to give you a presumptive bacterial identification. So if you see the red and a little bit of growth, then you kind of have a good idea of whether or not it is E. coli 157H7 or just normal E. coli, but it's not going to give you a definitive answer. So there's a few ways that we're going to be able to confirm a bacterial identity. So the identification. So we have our biochemical reactions. This is a API bacterial ID strips, which will be next week. Then we have immunoassays, which are going to be using pathogen-specific antibodies. And then we have gene probes, or PCR assays, which are going to use pathogen-specific gene priming or probing. So you don't have to document anything in your lab notebook because you're not going to be turning that in anymore, unfortunately. But make sure you know this information. It'll be helpful for the final. So for VRBA, which is going to be your coliform count. Coliforms are going to appear as dark red colonies of at least 0.5 millimeters. And then, so for Baird Parker, this is going to be for your staph. So your staph aureus is going to be black with a white margin around it, kind of like a halo. And then other staph are going to be black without this clear zone, and they're going to have a smaller amount of growth. So it's going to be selective for staph aureus. It's going to allow for that one to grow the best. Okay. So for different bacterial isolates, in order to identify them, we would be performing these tests. So for gram-negative rods, we do EMB and then an oxidase test, so testing for this enzyme. And for gram-negative cocci, well, it'd be unlikely. Okay, so most of your cocci are going to be gram-positive, or rods. Okay, so you don't really have to worry about this for your final or anything. This is mainly just for our APC. Okay, so gram-positive rods, then it's going to be, if it's a spore former, then you're going to have a B series selective auger. You're going to use that. Or if it's a non-spore former, then you'll use the catalase test to figure out which one it is. If it's gram-positive cocci, then you're going to be using the catalase test. And from there, if it's positive, Biochrom Staff and Baird Parker. Okay, so E. coli 157H7 detection. We have this antibody test. And so basically if you put your sample right here, and then you wait some time, and then, so about 20 minutes, and then if there are two red lines, then it's going to be positive, and then if it's a single red line, then it's negative. Okay, so you have your control and then your actual positive identification. So you need to have both of them be red to have a positive result. Then for salmonella, it's the same idea. So you have your control, and you have your test. So if it's positive, that means your control is true, your test is positive, it's also true. And this is where you put your sample again, right here at the bottom. So it's the same idea. If you do not have a red line for your control, then that means that the test is invalid, and you're going to have to redo it. So very similar process for all these, very similar tests. They just test for different antibodies. So then this very last one is for listeria. So again, a positive result is two red lines, and then a negative result is a single red line, okay? And that's it. So just make sure to do parts A through D for your food safety project report. And if you have any questions about that, please email me. I'm going to have parts A through D due as an assignment here on Blackboard. So be sure to check for that right here. So just make sure you have it turned in by 5/1 at 11:59 p.m. If you have any questions, email me, and good luck.